Okay, I'm going to start this section off by kind of deviating from the notes a little bit. I'm going to do what's in the notes. I'm just going to do it using Desmos instead. So I've got this graph and it's e to the x. It's a solid red line. And I also have a point on the line and a tangent line that go with it. So I want to start by looking at the tangent line at x equals 0. So there's a couple things to note. When x equals 0, the function, this solid line here, e to the x, when x equals 0, the y value is 1. Another thing to look at is the tangent line. So if you think about it, the slope of this line is up 1 over 1, up 1 over 1, which means that it has a slope of 1. So this is a very important thing to notice. When you plug in x equals 0, you get a y value of 1, and 1 is also the slope of that line, that tangent line. So I claim that this is true if we also choose 1. So if I choose 1, when I plug x equals 1 in, I get a y value that looks like a decimal. So e to the first power, and now that I'm saying it, e to the first power is going to just be e, so 2.71828, blah, blah, blah. So my claim is that this point, when I plug in 1, I get e as my output, but I claim that it's also the slope of the tangent line. So we'll pick this point and this point, and now I want to take this point and figure out what the slope is. So to do the slope, I would do 2.718 minus 0, and then divide it by 1 minus 0. So let's do that. 2.718 minus 0, and then divided by 1 minus 0. So that gives me 2.718. So you might be asking yourselves, why are these different? And that's because when I click this button here, Desmos can't just put all the decimals. The decimals would go off the page. So they just gave me the first couple of decimals. So just to repeat what I'm getting at, and let's actually check this with kind of our minds. It does make sense. So you go up 1, up 2, up 0.718, and then over 1. So this does make sense that that's a slope of 2.718. But to recap, what I'm saying is that when you plug in a value, like x equals 1, you get an output, e to the first power, and that output is also the slope of the tangent line at that point. That's pretty cool. Let's do one more. I think the last number in the notes is negative 0.5. I hope that's it. So when I plug in x equals negative 0.5, which is right here, I get an output of 0.607. Okay, so that's the output. And what I'm saying is I think 0.607 is also going to be the slope. So I've got this slope here, and let's just pick this point here because it's an x-intercept, and this point here. Okay, so to figure out the slope of the line between those 2 points, I would do the y values, 0.607 minus 0, which is pretty easy. It's just 0.607. And then I would subtract the x values, negative 0.5 minus 1.5. So let's do that. So the slope should be 0.607 divided by negative 0.5 minus negative 1.5. And boom, that gives me the exact same thing. And this does make sense because, let's see, does this look like, so negative 0.607 is a lot like 1/2, like you'd go up 1 over 2. So yeah, this does make sense. So the point I'm trying to make is that it seems like the original function and the derivative very much coincide. So keep that in the back of your mind, and we will go back to the notes.